Okay, so looking at problem 16, a sample of plutonium is known to contain 4.5 times 10 to the 18 atoms. How many moles? So in this case, we're given atoms, we want to go to moles. So in this particular problem, what we are given is 4.5 times 10 to the 18th atoms. In this case, plutonium. And what we want are moles of plutonium. So we go 4.5 times 10 to the 18th atoms, and this has to be plutonium. We put a conversion factor in that puts atoms of plutonium down here, and we put moles of plutonium up here, so we can cancel those units. And in any 1 mole of anything, there are 6.022 times 10 to the 23rd atoms. And so it's going to be 4.5 times 10 to the 18th divided by 6.022 times 10 to the 23rd atoms. Because in any 1 mole of anything, there are 6.022 times 10 to the 23rd of those. So that's question 16. Now moving on to 17. A compound is composed of, now we're moving on to these percent by mass problems. A compound is composed of 79.3% tungsten, 21.7% oxygen. So in this case, I'll move this over here. So we can write down what we have. In this case, so we have a sample. 2 things in that sample. We have tungsten, and that is 79.3% by mass, and the other one is oxygen, and that is 21.7% by oxygen. Now I'm going to assume, just for simplicity's sakes, that I have 100 grams in my sample, and that allows me to make these directly converted into grams. So I start with 79.3 grams in my 100 gram sample of tungsten, and I have 21.7 grams of oxygen. I need to convert each of these into moles. So in this case, I'm going to take grams of tungsten goes on the bottom, and I want to make that moles of tungsten on top. And then I'm going to take that same thing down here, grams of oxygen, and I'm going to make that moles of oxygen on top. And I know it's 16.00 for oxygen. I have to check and see what it is for tungsten. So we'll find tungsten right here, and that is 183.84. 183.84 per 1 gram. And then I have to do that arithmetic, and that will tell me, because I can cancel those units, how many moles of tungsten I have and how many moles of oxygen I have. And what that turns out to be then is 0.43. And this one over here turns out to be 1.36. 1.36. Okay, I'm going to expand this so we can make this a little bit bigger. So now my next step is to express this as the ratio. W is 0.43. O is 1.36. Now divide by the smallest number, 0.43, 0. So when you do this, you're going to get W1, and then O turns out to be 3.15. And right there, that's a difficult ratio. And you have to ask yourself, the question is 3.15 equal to 3. Remember I said how to do this. You take 3, 10% of that would be 0.3, 5% of that would be 0.15 that means, and that means we are within that. So not only that says we should be WO3, but if we go back and look at the choices, the other choices are WO, it's not that. It's not WO2, it's not WO4 because we have to multiply by quite a large number to make 0.15 a whole number. So our best choice here is WO3, but I want you to look at the problem, first of all, and take 79.3 and add 21.7 to that. 79.3 plus 0.7 would make 80, plus 21 makes 101%. So these numbers are not right, and it's probably supposed to be 20.7, and if you put those numbers in, I think you'd find that to be exactly 103. So that's a typo. That's supposed to be 20.7. If you did that, you would get 103. That's beyond what I expect you to know, but if we go back to our rules, we look at W and O, 3.15. It's within 5% of the whole number being 3, so we call that WO3. Okay, moving on to 18. Solid aluminum reacts with gaseum oxygen to form aluminum oxide. So this is a question. I give you the formula in words. Aluminum, solid aluminum. So we've got Al solid, Al solid, Al. Doesn't say solid, not a good chemical reaction. And down here it does say Al solid. So those are good. Gaseous oxygen. So we have O2 gas, O3 gas. Oxygen is O2 in its elemental form, and AlO2 gas down here. So we've eliminated these middle two as options. And then it says it forms solid aluminum oxide. There we have solid aluminum oxide. There we have solid aluminum oxide. Okay, so we've got to look to see if this is balanced. 1 aluminum there, 2 aluminums there, not balanced. O2 there, 3 there, not balanced. 4 aluminums, 3 O2s, 2 times 3 O3, that's balanced. You have to, by going through this step by step, you see the only answer there that could be right is that first one for question 18. Now, question 19. Naphthalene, better known as mothballs, undergoes combustion reaction to form carbon monoxide. So it gives you the formula, tells you it undergoes reaction with oxygen, and it forms these products. Now, read carefully. It tells you in this reaction, it forms carbon monoxide, not dioxide as we typically think when we think about combustion reactions. So in this case, we have naphthalene, C10H8. So we have our C10H8 plus O2. Now it gives us carbon monoxide plus water. And then we just follow our rules to balance. So we start with carbon because it isn't hydrogen oxygen. So we have to have a 10 here. We then balance hydrogen next because it's in fewer compounds. We have an 8 here, so we have to have an 8 over here. And the way we're going to do that is by putting a 4 there. And then we add these up. We've got 10 oxygens there plus 4 times 4. It's 4 oxygens there, a total of 14 oxygens. We can get that by putting a 7 right in there. So it's going to be 1, 7, 10, and 4. And we hope we see that as one of the possibilities. Oh, it says what is the coefficient from the oxygen. And indeed, that coefficient from the oxygen has to be a 7. And that is one of the choices. So we're good. And that is problem 19.